Today we're looking at section 8-4, testing a claim about a mean, and in particular we're focusing on the case where the population standard deviation sigma is not known, and that we'll be skipping over part 2. Again, this is the case where sigma, the population standard deviation, is known. So we're going to skip over that again. So our assumptions in testing a claim about a mean where the population standard deviation is unknown is the sample is a simple random sample. The value of the population standard deviation, sigma, is not known. Either or both of these conditions are satisfied. The population is normally distributed, or n is greater than 30. So that's what's required for us to use the t-distribution. Okay, our test statistic for testing a claim about a mean when sigma is not known is a t-value, so we are using a student t-distribution. T is equal to x bar minus mu times the square root of n over s. And again, this is my rearranged formula of the one in the textbook. I prefer working with the simple fraction. It's much easier on the calculator to do that. So our process for testing the hypothesis is the same for the mean as it was for the proportion. The only difference is that when we work with the mean where sigma is not known, we will use the student t-distribution to determine the critical values and to calculate the test statistic t. Otherwise, the process remains the same. Okay, let's keep that formula showing. So we have an example. A simple random sample of 40 recorded speeds in miles per hour is obtained from cars traveling on a section of Highway 405 in Los Angeles. Okay. The sample has a mean of 68.4 and a standard deviation of 5.7. Use a 0.05 significance level to test the claim that the mean speed of all cars is greater than the posted speed limit of 65 miles per hour. So our null hypothesis is that the mean equals 65. Our alternative is that the mean is greater than 65. And that's our claim that we're testing. Okay, so we need to find our test statistic. Our degrees of freedom will be 39. And our alpha, this time greater than, we're going to have a right tail test. So our alpha is over here 0.05, so it's in the one tail. Okay, let me find my table. So we need to use area in one tail is 0.05. So it's the top row there, 0.05, we find that. And we want to go down to degree of freedom is 39. And I'm getting 1.685. Okay, so our test statistic gives us x bar minus the mean from the null hypothesis times the square root of 40, that's our n, divided by the standard deviation, 5.7. Minus 65 equals 3.4, and we want to multiply that by the square root of 40, and that's 20 equals 21.5, etc. And I'm going to divide that by 5.7, and I'm getting 3.77. So that means here's our critical region. There's 1.685. So we're way out here. So we're going to reject the null hypothesis because we are in the critical region. Alright, so we want to go back to, I believe it's 391. Nope, not 391. In the wrong book. In my old book, I need to be in the new book, so maybe it is 391. Okay, it is 391. Alright, so the claim does not conclude equality, and we're rejecting the null hypothesis. So we end up with the very first wording, there is sufficient evidence to support the claim. And let's see if I've got room to here. That the mean speed of all cars is greater than the posted 65 miles per hour. Okay, so you can see it looks very much like what we did with the proportion. The big difference is we are using the student t distribution. So to calculate our test statistic, this is still our test statistic, and also to find our critical value. So those are the two basic differences between what we did with proportions and what we're doing here. So because we're using the t distribution, we have to be concerned with our degrees of freedom. Want to make sure this is only on one tail. Okay, so area in one tail, alpha is 0.05. If it were not equal to, the area would be in two tails. Okay, but for greater than and less than, it will be the two tails. It will be the greater than and less than will be one tail, whereas not equal to is two tails.